Assalamu alaikum. Dear students, in the previous video we learned all about the fractions. Today we will continue the second part of the chapter 1, different types of numbers. By the end of this video, you will be able to perform calculations on powers, write the number in scientific notation. Please prepare the following materials. Today we will talk mainly about the powers. First, writing decimals using powers of 10. So let us start by the following activity. Complete. Please pause the video and try to solve this activity. Solution. As you know, in part 1, 0.0064, here we have 1, 2, 3, 4 decimal numbers after a decimal point. So 0.0064 equals 64 times 10 to the power minus 4. Similarly, 23.5, since there is a one number after a decimal point which is 5, so 23.5 equal 235 over 10. We can write it 235 times 10 to the power minus 1. Powers in the denominator is 1. It goes up with negative power to the numerator. Finally, 74,000. We know that 74,000 equals 74 times 1,000, which is equal to 74 times 10 to the power 3. So we conclude that any decimal number can be written in the form of a times 10 to the power n, where a and n are integers, using 1 over 10 power p equal 10 power minus p. Powers change its sign when it goes from denominator to the numerator and vice versa, which is equal to 0.0 up to 0.1, and these zeros represent the numbers of p. That means p zeros. And 10 power p equal 1 0 up to 0. Also these zeros represent p zeros. This is an application. Write the following numbers in the form of a times 10 power n, where a and n are integers. Please pause the video and try to solve this application. Solution. 0.0081. Here 81 is an integer, and we have 4 numbers after the decimal point. Thus, 0.0081 equal 81 times 10 to the power minus 4. 2. 780,000. You can make it in the following way. 780,000 equals 78 times 10,000, and 10,000 is 10 to the power 4. Hence, 780,000 equal 78 times 10 to the power 4. Or you can make it as a previous way. Put a decimal point behind the last zero, and we have 4 zeros before the decimal point. So we write 780,000 as 78 times 10 to the power 4. Finally, 2.625. Here we have 3 numbers after a decimal point. So we get 2,625 times 10 to the power minus 3. Now, what is the scientific writing? Exponents provides an efficient way of writing and computing with very large or very small numbers. For instance, the Earth is about 150 million of kilometers away from the Sun. It's more convenient to write such numbers in scientific notation. So the property of scientific notation is as follows. A decimal number can be written in scientific notation as b times 10 to the power p, where b between 1 and 10, 1 included while 10 is not, and p is an integer. So we can say that the Earth is about 1.5 times 10 to the power 8 kilometers away from the Sun. Means that the scientific notation of 150 million is 1.5 times 10 to the power 8, which is true, since 1.5 represents b, and it is between 1 and 10, and p equal 8 is an integer. Example. The scientific notation of 0.0314 is 3.14 times 10 to the power minus 2. Also, the scientific notation of 134.72 is 1.3472 times 10 to the power 2. This is an application. Write the following numbers in scientific notation. Please pause the video and try to solve this application. Solution. Recall that a scientific writing is to write the decimal numbers in the form of b times 10 to the power p. So in part 1 we have 0.0000572. We start moving the decimal point to the right of the number, up to catch the first non-zero number. Here we move 5 places to catch the first non-zero number, which is 5. so we put the point between 5 and 7. So we get 0.0000572 equal 5.72 times 10 to the power minus 5. 5 represents the number of moving the points, and the power is negative since we move the point to the right sense. 2. 149,400,000. Here the number is an integer. We put the decimal point behind the last numeral, which is 0, and we move it to the left sense to make the number between 1 and 10. So we move 8 places and put the point between 1 and 4. So we get 1.494. This number is between 1 and 10, and the power of 10 represents the number of spaces, which is 8, since we move it in the left sense. So the scientific notation of 149,400,000 is 1.494 times 10 to the power 8. Finally, the scientific notation of 25.4 is 2.54 times 10, which is true, since 2.54 is between 1 and 10, and the power of 10 is 1, since we move 1 places to the left sense. Now, operations on powers. A and B are non-zero numbers, M and N are integers. These are the properties of powers. First property, A power M times A power N equal A power M plus N. We have same number, but different powers, and the operation is times, so we add the powers. Example, minus 3 power 3 times minus 3 power 4 equal minus 3 power 3 plus 4 equal minus 3 power 7. 10 power minus 5 times 10 power 2 equal 10 power minus 5 plus 2 equal 10 power minus 3. Also, 2 power n times 2 power minus n equal 2 power n plus into minus n equal 2 power n minus n equal 2 power 0, which is equal to 1. Second property, a power m over a power n equal a power m minus n. They have the same number, different powers, and the operation is divided, so we subtract the powers. Example, 5 power 7 over 5 power 4 equal 5 power 7 minus 4 equal 5 power 3. Also, 10 power minus 5 over 10 power minus 1 equal 10 power minus 5 minus into minus 1 equal 10 power minus 5 plus 1 equal 10 power minus 4. Now, third property, a power n times b power n equal ab power n. Here, the two numbers are different, but they have the same power. So we multiply the numbers and we put it in the same power. Example, 5 over 3 power 7 times 3 power 7. The two numbers 5 over 3 and 3 have the same power, which is 7. So it is equal to 5 over 3 times 3 all to the power 7, which is equal to 5 power 7. Also, 0.2 to the power 12 times 5 power 12. These numbers have the same power. So it is equal to 0.2 times 5 all to the power 12, equal 1 power 12, which is equal to 1. Fourth property, a power n over b power n equal a over b all to the power n. Example, 16 power 8 over 4 power 8 equal 16 over 4 to the power 8, which is equal to 4 power 8. Also, 3 over 5 power 3 equal 3 power 3 over 5 power 3, which is equal to 27 over 125. Fifth property, a power m to the power n equal a power m times n. If we have power to the power, then we multiply these powers. Example, 10 power minus 2 to the power 4 equal 10 power minus 2 times 4 equal 10 power minus 8. Also, 2 power 3 times 7 power 4 all to the power 2 equal 2 power 3 to the power 2 times 7 power 4 to the power 2 equal 2 power 6 times 7 power 8. The final property is a power minus n equal 1 over a power n. Note, a power minus n and a power n are reciprocal numbers. The sign of a power is changed when we change its place from numerator to denominator or vice versa. Example, 2 power minus 3 equal 1 over 2 power 3 equal 1 over 8. Here, the powers of 2 is minus 3 in numerator, which is negative. It goes down to the denominator and becomes 2 power 3, which is positive sign of a power. Also, 3 over 7 power minus 1 equal 1 over 3 over 7 equal 7 over 3. This is an application. Simplify the following expressions. Please pause the video and try to solve the application. Solution. Using the properties of powers, we will solve this application. In part 1 we have 3 over 5 power 2020 times 5 over 3 power 2021. 5 over 3 power 2021 equal 1 over 5 over 3 to the power 2021 equal 3 over 5 to the power minus 2021. 3 over 5 power 2020 times 3 over 5 power minus 2021. Now, these two numerals have the same numbers, 3 over 5, but they have different powers, and the operation between of them is times. So we add the powers. 3 over 5 power 2020 plus into minus 2021 equal 3 over 5 power 2020 minus 2021 equal 3 over 5 power minus 1, which is equal to 5 over 3. 2. 7 power minus 2 times 5 power 5 times 2 power 5 over 2 power 4 times 5 power 2 to the power 3 times 7 power minus 4. We start work in 5 power 2 to the power 3 equal 5 power 2 times the 3, which is equal 5 power 6. So we get 7 power minus 2 times 5 power 5 times 2 power 5 over 2 power 4 times 5 power 6 times 7 power minus 4. The operation between the numbers is times, so we can perform the numbers. Then 7 power minus 2 over 7 power minus 4 equals 7 power minus 2 plus into minus 4 equals 7 power minus 2 plus 4 equals 7 power 2. And 2 power 5 over 2 power 4 equal 2 power 5 minus 4 equal 2. So in the numerator we get 7 power 2 times 2. And 5 power 5 over 5 power 6 equal 5 power 6 minus 5 equal 5 power 1 in the denominator. Hence the expression is equal 7 power 2 times 2 over 5, which is equal to 98 over 5. Finally, 0.125 to the power 2n times 8 power 2n. Two different numerals have same power with the times operation, so we use the property a power n times b power n equal ab power n. Thus, the expression equal 0.125 times 8 all to the power 2n equal 1 power 2n, which is equal to 1. Please review pages 7 and 8 on the textbook and solve exercises 2 and 3 on extra sheet. This is the summary of the chapter. Please study and write it in your notebook. Dear students, stay safe and healthy.